You're all set, Nabi. You can start.
I can start. Okay.
Yep.
So good morning, good afternoon, everyone, and where you are. It's my pleasure and honor to host for our coffee chats Dr. Hamad Hanifi he's the head of research and development at EE Solar. And the topics of today is fit perfectly with his expertise and interest of development is the cost versus the quality versus the cost LCOE and how we can cope and remain at high level of the quality, ensuring the reliability, the durability of the performance while we are squeezing the costs. And this is also with the targets to be more competitive for the solar industry. Before we go in our discussion, Hamad, I would like to ask you to introduce yourself in a few words and your company, please.
Thank you very much, Nabi, and I would also like to say hello and welcome everyone to this coffee chat. It's a very nice idea. Thank you very much, Nabi, again, and your colleagues. My name is Hamad Hanifi, and I'm head of research and development at EE Solar. My background is electrical engineering and photovoltaics, and and previously I was working with Fraunhofer Center for Silicon Photovoltaics for almost 8 years, where I was working in the groups of module technology and module reliability. And my main focus was, as I mentioned, module technology and reliability, and with a focus on extreme climates, especially desert areas. And since last year, I joined EE Solar. EE Solar is a module producer, a tier 1 module producer, which is active at the moment in 95 countries. And we have at the moment 2 production lines in China and Turkey with a total capacity of 2 gigawatts, which is now in planning for further development and hopefully very soon in Europe.
Okay, thank you, Hamad, for that short introduction. I would like to start saying this, that to thrive in the solar energy sector, manufacturer and retailer need to ensure that their products meet established quality and performance standards. This means demonstrating that their PV modules are robust and able to constantly deliver the guaranteed rated power reliably, even under more severe climate conditions. They must also be safe and durable, ensuring that system high level yield over the long term and still need to be viable and cost effective. So this is a dilemma. We always say you get what you pay for, not what you expect. What is your opinion about that, Scott Hamad?
Yes, that's a very, very big challenge at the moment in PV industry, because as we see historically, the price of photovoltaic, okay, not considering the past 2 years, but the price of photovoltaic was decreasing. And now still the solar energy is the cheapest energy in the world. However, again, it comes to quality, because most of the solar projects should live between 25 to 30 years. Here is where you give performance guarantee as a module producer, and this is also a big factor when you're planning a PV project. So if a project developer or the project owner is developing a project, they calculate it for 25 to 30 years. And here it's always a big question that what are the factors to be considered? Because most of the times we see, as you mentioned, you get what you expect, what you pay for it, not what you expect. But it's also very important to see how you look at the costs, because in many cases we see that people look at the cost of the project. So what they consider is mainly the initial costs. However, what it needs to be really considered is a levelized cost of electricity for that specific region, because this is very important then yeah, you can, for example, go and buy a module which is cheaper, but has a different bill of materials than another module which is robust and more compatible with the climate in that region. And although you save like 1 to 3% in your money in the beginning, but in long run, so in 30 years, you might not be the winner when the modules start to fail after 10 years. So this is a kind of dilemma. This is a kind of really big challenge that it's at the moment also existing in PV industry. And I think the main solution or the first step to do it is basically to look and levelize cost of electricity, not the initial investment. And second of all, that to get proper people who can understand, who have the understanding about the region and the technology when they want to plan the project.
Yeah, this is very interesting point, because you mentioned that we have to look into, rather than the cost per watt, we have to look into the levelized cost of electricity. This is a really key point. Before in the past, we were all focused on how much cost a module, and that's it. But today, with all the technology developments and all what we witnessed worldwide since, I would say, 12 years, we shift, the paradigm had shifted, and we start considering rather the cost per watt, rather the LCOE instead of the cost per watt. In the beginning of the solar, when the solar stack was subsidized through different mechanisms like feed-in tariff, for instance, or other mechanisms, tax incentives, and all these things. But today we are looking about how much costs, and today most of the projects are based on auctions. So there is no more feed-in tariff in any projects, I guess, worldwide. Well, I heard that recently which country? South Africa introduced a new feed-in tariff for the rooftop, which is interesting. But this is a very, very key point. And rather than keep looking, and through that, of course, we can see exactly how the materials are important outside the materials. What is called materials is the BOM for the modules, and the BOS for the entire system. I read recently one article that says that the PV community insurance witnessed an air crack, which regarding the quality issue. And during the last 2 years, it was published by a third party who is making tests. That during the last 2 years, 2021, the insurance, the quality problem has, I would say, increased 20 times in comparison with 2019. Did you heard about that? Anything? Do you have any comments on that? Why suddenly we have that number of problem? Is this due to the quality? I don't know exactly if it's. What is your opinion?
Well, actually, you gave a lot of interesting keywords for me to give the answer, and I would say that it's a combination of different things. So one of them is the combination of the system. For example, you mentioned auctions. When you go in the tendering phase and you, for example, for a project, you go into the tendering phase and you give the project. So people start to give prices, or beats, or bid on the prices. And what we see is most of the time, this is also a challenge that we face, because time to time we see that the project developers who are working with us are facing with this problem. For example, let's say that there is a tendering system in United Arab Emirates or Saudi Arabia. Here, of course, you need to bid the lowest price. And the lowest price will be a glass backsheet module. of course, this is cheaper than the glass module. But what makes sense that you pay 3% more and get the glass module for this area? So you have very significantly more reliability compared to when you have only glass backsheet. I mean, relatively speaking. However, you have 3% difference in the prices. So in the tendering, you can't really argue with the person why you cost 3% more, or you want to sell glass module. You have to beat the lowest. And that's a problem. That's a problem because the people who, again, I come back to your phrase, you get what you paid for. And when you want to have the cheapest thing available, it will not result in the best project that you imagine, because most of the people also in the purchasing system, they check some factors like the standards, what you have from whether you have IEC 61215 or 67030. However, these are the minimum requirements, and they are mainly developed for moderate climates, for example, not for the desert. And they say, okay, that's a guarantee that, for example, module manufacturer also gives, but there is no guarantee on the guarantee. You can buy it from one company, and after 20 years, you see that the company is not existing there, that you can do the claim. And I wouldn't say that it's just valid on modules which comes, for example, from China or Asia. We already saw some big companies in Europe that it is only a name remain from them. So this is like one issue, the price. So when you need to beat lower, then you go for the cheaper option, and the cheaper option is not necessarily the best option for that region. And this is, for example, one problem that you have. The other one is quality problems. Of course, when you want to squeeze the price, you always sacrifice in quality. I mean, not always, but in most cases, in case that you choose in the fabrication side to go for a cheaper material, which is not in a good standard that you expect, or on the other hand, for example, as I mentioned, you go for a total product which is not dedicated for that or not compatible for that specific country. Here again, it comes to quality problems, but one factor, another factor. But the third one is also the amount of installations that we see at the moment is significantly higher compared to the installations that we had, for example, 30 years ago. So the statistic is also higher. But with the statistic, you have more challenges. With more projects, you have more people who are working in that project, and not most of them are skilled people. So sometimes you see that there are some problems with the sites. You see that it's failing, but it's not because the module quality is lower or it's cheaper or whatever, or even the environment, but it's the way that it is installed or the way that it's maintained. We see many times that the installers who are installing the PV module walk on the module or put the knees on the module to make the screws tight. And we also see that the people who are doing the maintenance and washing the modules, especially in some countries that the labor forces are cheaper, you see that in many cases they really handle the module with no care. Many times they walk over it and they clean it with mops. And sometimes you see, for example, I mean, I even saw one video on YouTube with almost 3 or 2 million views, that a guy was telling he was an installer. He was saying that people think that PV modules are, the solar modules are brittle, but it's not the case. Look, I'm walking on it. And they were showing the process of installation. You saw that people just knee over the module and try to screw it. And this video had 2 million views. And on the other hand, I saw a video from NREL, National Renewable Laboratory in United States. We see that they had a video of a electroluminescence camera that when a person is walking on the module, what happens to the module? And this video had only 50,000 views. So we see that these sort of installers and this sort of, for example, wrong maintenance and wrong installation also is the case of problems and failures that we see these days. So I would say in general, it's a chain of some wrong decisions or wrong people or lack of education from many sides, for example, from the purchasing side, from the installation side, each of them separately, which results in more defects and failures in the PV modules. So I would say it's a combination. It's not only like one factor.
Yeah, I think you're completely right. And I jump on what you said at the end, that it's a combination of a lot of things. And the biggest one is the awareness of the people. And one of the things that I would like to mention that we did with Solar United working group, and we produced a report studying the quality from the polysilicon production to the kilowatt hours, and of course, through all the steps of the production, manufacturing of the modules, installation. And what we noticed, and I don't remember the number of sites that has been assessed for that study, that over 70% of the problems are mainly due to the EPC, to the installation, rather than in the module, cells breakage, burning of the junction box or other things. It's mainly due to the installation. And the installation is one of the biggest problem in terms, because people lack the knowledge and they need more training. But there is another point that I would like, because I was really shocked when I learned that during the last 2 years, the number of revealer increased by 20 times than in 2019. As the market turned from a seller market conditions to the market seller conditions, do you think that the manufacturer lowered the quality specification of their product?
I'm sorry, I lost your voice when you were talking. So for a short,
okay.
Can you please repeat the question?
Okay, the market turns to seller market conditions rather than the buyer conditions. Do you think that the manufacturer lowered the quality specification of their product?
So we see at the moment that some specific modules are coming to the market. So we see, for example, modules. If you look at the international technology roadmap for photovoltaics, we see that modules for extreme climates, for example, are emerging. And we are also getting a big niche market in customized applications such as vehicle integrated and building integrated. But if you're talking about the commercial modules for field installation or rooftop installation, we see that there is now a big turn, because previously it was not in a way that, or still in many cases, there are like 2-3 types of modules, and the big module producers start to mass produce it. And this is independent from the location. They want to sell it anywhere. And but we see that according to the numbers, a share of the modules which are specific for desert conditions or tropical places or highlands are emerging. The share is not that big because the share of the market demand in these regions is not that high, although they have the highest potential. For example, we see that in North Africa or Middle East, you have a very high potential for PV modules. So imagine in case that you cover about 300 to 300 kilometers of the Great Sahara with PV panels, you come over 20-something terawatts of power. So in a really theoretical way, but it shows how big it can be. However, there are a lot of chains. We see that the biggest market for renewable energy, the installation, is at the moment in China and then in the United States. And then we see, for example, in Japan, in Germany, and etc. But these are not exactly, okay, in part of China and United States, yes, but in general, in average, they're not the countries with the highest irradiance level. So the demand for these modules is not at the moment that high, and specifically with the decision makers in these countries try to go, most of these countries in some cases are very price sensitive. And the others also, although they might not be the price sensitive, but they like to go everything through tendering and have the lowest price. And that's the reason, again, you cannot go customized in many cases. And the second thing is that from the manufacturer point of view, in case that you produce a desert module, let's say, you have to store it. It means that you have to pay for the storage for your warehouses. And you have to wait that someone comes and buy this module. So in some case, it's not that easy to come with the perfect solution unless that you are flexible enough that you can do the order and produce based on order. And that, again, it's not a perfect way for manufacturing because you have to do changes in your BOM and in your recipes of the production. So there are many challenges. I wouldn't see that in the near future we see a big share on that, but I would say it's a very strong niche market inside the commercial market.
Yeah, that's bringing me to link that with the other point that I was thinking about is, and you mentioned yourself regarding the conditions where you use the modules tempered climate or arid climate is completely different conditions. So how can we mitigate the risks and improving the lifetime and the reliability of the products?
I would say that the best case is that we get some technical people who really have understanding about the PV modules and other BOS components. This is very important because we shouldn't just trust what is on the papers, and we really need advice from the technical people. I will bring an example, and I will tell you actually how you should think about it ahead, and how are the factors that you need to consider to mitigate the risk and also decrease the levelized cost of electricity. And let me talk about, for example, desert condition. In the desert conditions, generally we have, I mean, in average, in case that we want to talk about, we have air mass of 1.0, almost. And considering that in the standards, we always considered AM 1.5G. So here we have almost twice higher UV dose. And considering that in these areas, we have also higher irradiance dose compared, for example, to Germany, we have almost 2000 kilowatt hour per kilowatt peak per year, compared to, for example, 900 to 1000 in Germany. And we see that we have twice higher irradiance dose and or the energy that we get from the sun, and twice higher UV dose. So we have almost 4 times higher UV dose compared to, for example, Germany. Then we have a higher temperature difference between night and day. We have higher ambient temperature. We have significantly higher soiling ratio, almost 50 times more. We have, in some cases, we have also a strong wind. And all these factors together put a high stress on PV modules. So what we need to know is, considering when we want to do a PV project, not to consider how much it costs in the beginning, but see a bigger picture and see how much it's going to cost us in 30 years. So considering these factors, which I told you, and in case that we want to consider it in levelized cost of electricity, when we have a higher temperature difference between night and day, we have more movement of solar cells inside the laminate. This leads to the fatigue of ribbons and breakage of the copper ribbons. This is a failure. This is something that we have to consider in our planning and go for a modules which have a smaller cell size. This is just an example. Or this means that we can have a module which gonna live or last longer compared to another PV module. And talking relatively, we can have a module which can come close to 30 years in desert areas compared to the ones that we see which fail in 10 years. And this is actually a big market. We see at the moment, I would say that in the coming years, you're going to see a new product series from AE Solar, which is repowering PV modules. At the moment, we have a high demand on small modules like this and this size and back for repowering projects. And it's unbelievably big, even in Europe. So in Europe, we are talking about megawatts of recovering projects. And this is also a very big business area for the big EPC players in Europe. And consider that here is a moderate climate. So I would imagine, in case that we have more installation in Arabic countries, for example, in Middle East, in UAE, in Saudi Arabia, or Oman, it's going to be really interesting to see the installed modules which are already there, how long they're going to last. And I would say this is going to give a very nice indication about the lifetime. So you don't want to have a module which fails after 10 years, although you pay less, but instead of having a module in 30 years, you have a module for 10 years. And this is a wrong imagination. If you say, okay, after 15 years, I deinstall the PV modules and throw them out and put a new one there. So here I have twice higher irradiance dose, means that I produce twice more energy. So instead of 30 years, I do repowering earlier in 15 years, and I'm still the winner. But it's not the case, because when you have new PV modules and you want to install it, you can, for example, see the past 2 years, the PV module technology changed significantly. Now you have modules with larger solar cells with different dimensions, and you have different electrical properties. You have different dimensions, and know your other BOS components like the mounting systems, like your inverters, cables, fuses, and they all should be changed. Basically, you should trash your site and build it from the beginning, which is, again, a lot of cost, which should be considered from the beginning. When you want to have the removal costs, how much it's going to cost. Again, it can be considered in levelized cost of electricity. So these things should be really considered when you want to plan a project, and you have to really think about the lifetime. But lifetime is one factor. The other factor, which I also mentioned again, was in the beginning, was the maintenance. Time to time, when I'm talking to people, especially from Middle East region, the desert areas or North Africa, and they're talking to me about the prices of the PV modules. And we see that at the moment, we are somewhere between 25 to 30 cents per watt peak. And they're saying, okay, it's like too much. We're just going to put it there and it's going to produce energy, but they don't consider, for example, the cleaning costs. There was one study that they calculated in Saudi Arabia for 1 megawatt PV plant for 30 years. The cleaning cost for wet cleaning cost was $750,000. This means that you have, if you rate it down to the watt peaks, you have about 0.75 euro, so 75 cents per watt peak surplus on your PV modules, which cost between 25 to 30 cents per watt peak, that you, which is almost 3 times of the price within 30 years just to clean your modules. And when you give the numbers, they become shocked and say, oh, we were not thinking that it costs that much. And these are also one of the things that people really should consider when they're planning the project, how much the maintenance costs.
Yeah, absolutely. You're completely right. So this is why we have to consider the LCOE. LCOE normally it includes everything. It's not only include the module price or the BOS cost, but it will consider also the maintenance, including the cleaning and all these things. And this, you mentioned also in your answer that, for instance, there are a lot of power plants installations where are moving now, removing the modules to replace them with others because of failure, or even because that's the calculation shows, and with the development of the efficiency of the modules, they can produce much more, and the land is somehow, especially in certain area, very expensive. So they are removing. This constitutes a lot of second-hand modules. Okay, and this is a market which is under, I would say, development. Of course, that we cannot consider the second-hand modules as we consider second-hand car, because the usage is completely different and the target is completely different and the sensitivity of the usage is completely different. So having said that, the second-hand market, I would say that there are two major issues. One is in the performance, because we remove them of the quality, the performance, or the performance because we have better modules. So this is one issue. In comparison, all the modules have less power than today. You show the module behind you, 60 self modules. In the past, it was merely 150, 180 watts. Today is over 300 watts. Okay, so all technology. The other point is the quality. Do you think that there is a market that could be developed realistically with these modules?
Well, there are at the moment a concept of like the second life for PV modules. There are for some projects that they the site is failed, so you see a very underperforming string, so they demount the PV modules. Of course, not all of them are highly defective, and some of them can be reused quite well. We know that in many cases they can be exported with significantly lower price to other countries which have a lot of land, which the land is inexpensive, and they can be used there. So basically, with a very cheap price, you have an underperforming system, but it's better compared to not having a system. You have energy production. I think this can be a very big potential in the future, as you also mentioned, but it also comes with a lot of challenge because, well, in case that you can do the sorting of the PV modules, this also requires a lot of time and a lot of resources. That you should measure the PV modules and sort them according to their power classes. That you can, for example, have like several different pallets that they have different power classes that you can sort them in your PV system. However, as I mentioned, having the PV modules, transport costs, pallet costs, packaging, measurement of the PV modules, and etc., it again requires costs. So considering that the PV modules, a new price is 25 cents per watt peak or 26, and it can even come lower. And then you have the second-hand modules that you should be really good in your or like optimized in this process, that you can make a business model out of it in a way that you can be successful. The other way is that you just sell it blind, like that you buy something like this wholesale stock modules. You just buy things. There are some new modules in it, some leftovers from some projects. There are some defected modules in it, and you install whatever is visually not defective. Okay, then you have very low performance system, but you can save a little bit of cost in the beginning. So finding an optimized point between these two would be a very interesting market, but this is something which requires a bit of thinking and practice. And I don't think that there are many players in this range. So I think this is a good opportunity. But beside it, also we should have an eye on the recycling of the PV modules in the future, because this will be also a very, very big market. the modules, we see that a lot of them are being trashed these days, and there are a lot of precious metals and materials in it, like silver, but as well as toxic materials. For example, the glass itself, to have a higher clarity, has toxic materials in it, or the thin film modules. So they have to be recycled properly. So this will be also a big market in the near future, or this should be.
Yeah. Thank you, Hamad. I want just to pick up before, because we already reached or overpassed the time scheduled. So I would like just to pick here few comments and maybe question from the audience. Is Pietro Mena says that LCOE doesn't provide alone an accurate measure to compare among energy generation technologies. LCOE doesn't capture energy value, capacity value, and flexibility value. Any comments?
Probably I did not understood the question. So LCOE does not provide alone an accurate measure. I am not quite sure that I understood the question properly, but here it's not clear for me what he means by energy generation technologies, whether we're comparing wind with solar or we're comparing different solar technologies. This is not quite clear for me. And also the words capacity value and flexibility value is also unclear for me.
Well, maybe I just put some comments to Pietro, because for sure that there are different technologies, and for instance, just the thermal coefficient is different between the heterojunction and the monopack, and the calculation of the LCOE will be affected. If we take, for instance, I don't know, the bifacial or single side modules, of course, that the calculation is not the same, but nevertheless, the LCOE remain a very good indicator with certain margin of error that cannot be 100%. But in all the calculations that I have been performing and I checked myself, I saw that there is a margin of error. Sometimes is higher, sometimes is lower, but the difference is no more than 1 or 2%, which is a very good indicator. This is my opinion. The other point is regarding, I had also that in my mind, because we always say that the modules are certified and that's it. So they are certified, they are good quality, but this is not really the case, unfortunately. The certification that it's not 100% accurate with the reality. So here it's about the test, how to design a meaningful accelerated lifetime test protocol for PV modules for this special extreme circumstance like desert offshore PV.
Okay, so that's a very nice question. We tried it quite a lot when we were in the research institute. So first of all, how you simulate it in the climate chambers. So you can have like different simulation methods, either calculation simulation or even put the modules in the climate chamber. But I would assure you that in the real life, you get quite a different results. So with our experience, we are close to it always, but it's not exactly that you can estimate it in a way that you were expecting. So there is always one new parameter in the field which surprise you. As far as I know, there is already a standard procedure that you test the modules for extreme climates. And I think the first draft is already published. I'm not quite sure. I have to check it again. But as I mentioned, in general way, considering that it's an offshore, like desert or offshore PV, because it's like an exact example of it will be somewhere like Qatar. Which is like near the shore, and you have also desert in it. So this is like not that easy way that you say the lifetime test protocol, but there are some indicators. For example, in case that you consider some tests which are relevant to the climate, like thermocycling test, the damp heat test, the UV test, especially extended. So not considering what is in IEC 61215, which says like you have to consider it for like 70 kilowatt hours per year. This is nothing. All modules can pass that. So the main issue is that you have to consider is really accelerated. So in case that you don't have, in case that you want to really, you have to calculate for a longer lifetime. And here, so longer period to illuminate the module with UV dose, and then you can get a more meaningful result when you introduce some other accelerating agents like humidity in it. So this is one factor. The other factor that you need, for example, to desert-like conditions consider is the abrasion test. Again, extended abrasion test, and consider it with different dust and sand sizes. So there are like many different test stands, but something which has a wind tunnel, which would really simulate the real life scenarios more and more. Other factors that you need to consider again is tensile test, especially for your ribbons. And what I forgot to say. So
well, I think that there are several things to be done for tests, because the certification is one thing, but it's not insurance for the quality. We have whether to develop, I would say, a kind of in-house test for these modules, or to hire a third party to double check. But in any case, we have to be sure about the BOM and the material used in the BOM. This is the key point.
Exactly, that is the most important factor to be considered. For example, a person who wants to choose a proper module in desert areas, in my opinion, should definitely go for POE for the encapsulation material. Should also pay attention more in detail, for example, to have a UV transparent in the sun side and UV cutoff in the rear side to protect the backsheet, for example. Or many other factors which should be considered here to have, I mean, with these factors, as a rule of thumb, you can increase the module lifetime, let's say,
exactly.
for a
longer. This is what we expect. This is what we expect from the module, is long lifetime at higher level. I would like to bring Pietro on a stage. I don't know if I already push the button to answer directly. Are you, Pietro, are you with us?
Yeah, I am with you. Can you
yes, please, if you can
say
exactly what you mean to us.
Thank you very much for allowing me to intervene. No, I was just commenting on the Hamed intervention concerning LCOE. Of course, LCOE is a very attractive metric. It's just one number, you know, and you can sell it very well. On the other side, you know, if we have to compare among different technologies, when we have options, of course, then LCOE is not enough, because, you know, if we produce energy at a very, very low LCOE, the lowest that you can imagine, but we produce when I don't need it, for me, this energy has zero value. Okay, this this very simple logic is not reflected in LCOE. Then this is what is called energy value, what I have mentioned. Then you have the capacity value, which is something that when you talk energy system, you know, it's important having a capacity value, meaning to respond to the request of the energy system managing authority and flexibility value and so on. But, you know, the energy value, for instance, it's very clear to everybody. You know, we can produce and at the lowest possible cost. Still, if I don't need, when we are producing, for me, this is zero, the value, then even less than the lowest cost. This is the idea that LCOE is very attractive, but is not alone, is not sufficient. Thank you for, thank you.
Yeah, thank you, Pietro. I would like to apologize for our audience and our guest, Hamad. It was a very, because we overpassed widely, I would say, the time frame. And I would like to thank everybody for attending, and I saw some reactions here from the audience, and I'm very sorry that we cannot handle all this. Maybe this gives us another opportunity to have you, Hamad, in another coffee chat with the coffee, because we have to use our coffee. It's very important to have our mug for the session. I think that's myself. I really enjoyed, and I'm pretty sure that all the audience enjoyed. We really loved the information given by you, Hamad, from your experience and your knowledge about the quality issue and the problem for the performance of the module in a long run at a high level, and I would not say at a cheap cost, by a cost value. And I think that we have to orient our, I would say, language as we change the paradigm, from talking about the kilowatt, the watt peak to the kilowatt hours. We have to change our wording and our targets, rather than talking about how much it costs, the cost value, where we can show that we pay for what we get, but not we get what we pay for.
Yes.
I think, having said that, I would like to let the microphone to you for a short conclusion, Hamad, and thanks all the audience and the organizer of that coffee chat.
Thank you very much, Nabi, for having me here in this coffee chat. I'm looking forward to participate more often, and it is always a pleasure to talk with solar profis all over the world. From my side, again, I would say you already mentioned the conclusion that I wanted to say, and I stick again with the sentence that you said in the beginning: you get what you pay for it, not what you expected. And this is exactly what we need to consider when we want to do anything general. And we also should consider what we really need, because when we want to hang on something on the wall, we need a hole. We buy a drill for it, but at the end of the day, we're paying to have that hole. And this is something that we always have to consider, that we don't need watt peaks or euro per watt peaks. We need kilowatt hours in this side, and we have to also always consider how to do it to mitigate the risks and have the best price for the best performance, not just to have the cheapest.
Thank you so much. Brian, I handle the microphone to you. Hello, Brian.
I am here, Nabi, but for some reason my camera is not turning on. Excellent discussion between you both. Thoroughly enjoyed this particular session. All I could do is once again thank you for both of your time, and also for the audience participating. We do have another coffee chat coming up in the middle of August, which we're going to be focusing on the job opportunities in the PV market. I don't have the exact date in front of me, but this can be available.
It's the 10th of August.
10th of August, and
Yes.
you can register for this session at Solar United. So stay tuned, and thanks again for participating, and we'll have the recording up of this session if you want to review it in the next few days. So thanks again, and have a good rest of your day.
Thank you, guys.
Thank you very much.
Thank you, Hamad. Thank you, everyone.
Thank you.
Bye-bye.
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 Bye.